with the rapid growth of new energy vehicles. Ensuring the reliability of critical components, such as batteries, electronic control systems, motors, and sensors, has never been more important. But have you ever wondered how these components withstand the extreme temperature fluctuations of real-world conditions? In this video, we'll take an in-depth look at thermal shock chambers, the ultimate quality guardian for the reliability of NEV components. What is a thermal shock chamber? A thermal shock chamber is a specialized environmental testing device capable of rapidly switching samples between high and low temperature zones in a very short time. With dual or tri-zone designs, it can accurately simulate the sudden temperature changes that components experience in actual use. By repeatedly cycling through temperature extremes, it accelerates material stress reactions, revealing microcracks, solder joint failures, or seal degradation. This provides scientific verification of component reliability under extreme operating conditions. Applications in NEV components. Power batteries are the heart of NEVs. Thermal shock testing can simulate rapid transitions from -40 degrees Celsius to over 100 C, identifying potential issues such as microcracks in the casing welds, separator shrinkage, and insulation failures. This helps manufacturers meet safety standards and reduces the risk of costly battery recalls. The electronic control system is the brain of the vehicle. Rapid temperature cycling quickly exposes latent defects like cold solder joints, tin cracks, solder fatigue, and semiconductor aging. This ensures BMS motherboards and control modules operate reliably under extreme temperature fluctuations, safeguarding vehicle safety. Drive motors operate under high loads and endure combined temperature, humidity, and mechanical stress. Thermal shock testing verifies winding insulation, magnet stability, and seal reliability, ensuring efficient performance under extreme climates and long-term operation. Intelligent sensors are crucial for autonomous driving. Thermal shock testing simulates sudden environmental temperature changes, ensuring sensors maintain signal stability and precise responsiveness, providing reliable support for ADAS systems. Why choose DHT thermal shock chambers? Temperature range -70 degrees Celsius to 150 degrees Celsius, positive and negative 0.5 degrees Celsius uniformity, 5 degrees Celsius per minute ramp rate, German EBM fans plus Emerson compressors, hydrogen detection plus pressure relief valves, supports remote monitoring and USB data export.